length in degree mode. Now the arc length formula in radian mode is very, very nice, right? S equals r theta. It's a little bit more complicated when you're in degree mode. They're just not as useful in terms of the calculus. So for this problem, I'm actually going to do this in an alternative technique that works for radians also. It's a ratio or proportion approach. So we're going to look at part to whole, part to whole. I'm going to say S, the arc length we're interested in, is a certain fraction of the entire arc of a circle, which is its circumference. That's 2 times pi times r. And what ratio are we going to take? We're going to take the ratio of the central angle out of the entire circle's amount of degrees, and that would be 360. So this is nice because that means that you don't need to memorize a new formula. We're using 360 degrees as the whole circle. So in radian mode, you'd actually just put a 2 pi over there, and if it was some other kind of interpretation, you could also use the exact same approach. So let's apply it and see what happens here. Problem number 1 says the radius is 4 and the arc length is 12. So replacing our variables with their numerical values, arc length is, the radius is 4, the arc length is 12, so we have 12 for the arc length over 2 times pi times the radius, which is 4, is going to be equal to theta, the angle, over 360. So 12 over 2 pi times 4 equals 360. If you can isolate theta, we would multiply both sides by 360. So on the right hand side, you'd be left with just theta. And on the left hand side, I'm going to use a calculator because their numbers here are not excellent. I'm going 360 times 12 divided by 2 times pi times 4, and that's giving me an answer of 171.887. So in this problem, let's round to hundredths for convention here, and we'll say that theta would definitely be equal here to 171.8, and then the 7 would round the 8 up to a 9 many degrees. So round to whatever you have to, leave it exact if you need to, but that would be to the hundredth of a degree. Now watch what happens on the right when we switch up the variables or switch up the unknown. Now we know the central angle, and we know the arc length, but we don't know the radius. So the only difference is we're going to have 10, right, the arc length, over 2 times pi times r is going to be equal to what was given, which was 30 over 360. So in terms of the mechanics, it's not like a new formula we have to memorize when we're looking for something different. We just have a different setup. So in this context, if we cross multiply, 360 times 10 is 3600. 2 times pi times r times 30 would be 60 pi r. And so when we want to find r, we'll just divide by 60 pi on both sides, 60 pi, and what are we going to get for our r? The r is going to be 3600 divided by the quantity 60 and times by pi. So it looks like 19.098. Again, if you want to round to hundredths, this would be r is approximately equal to 19. The 8 is going to round the 9 up to a 0, which is going to carry over into a 10, so you're going to get 19.10 for that particular radius. So last problem, try one on your own after pausing the video and see if you can find the radius being 6 and central angle of 150, find the unknown arc length. The unknown arc length would be the S out of the total, which is 2 times pi times 6, equals the angle measure, which is known for the central angle, out of the total circle. So cross multiplication would yield 360s equals 150 times 2 is 300, and 300 times 6 is 1800 pi. Isolate the s by dividing by 360. looks like S would be equal to, just grabbing a calculator here, 1800 pi divided by 360. The arc length appears to be 15.707, and so with rounding to the nearest hundredth, this would be 15.71.